This is a production of Cornell University.
Thank you so much. I'm not sure I know the guy that he was talking about. It's a pleasure to be here. And I thought maybe the way to start this off would be to give you a sense of my personal journey. I got my master's and PhD in astrophysics at a university called University of Pennsylvania. I recognize them at Cornell. And I was working in planetary science for a little more than a decade and a half, and I decided to make a switch to full-time national science education. I've always been fond of both research and education. I remember when I was in high school, I worked as an amanuensis for the New York State Department of Vocational Rehabilitation, working with very physically disabled students who were brilliant, trying to take them to the next level up. And I felt that education was just so vitally important to what it meant to be me, that when I had a chance to, after my PhD, I had an opportunity to work as a National Resources Council postdoc at Goddard Space Flight Center, or help establish a lab for astrophysics at the National Air and Space Museum, which is the most visited museum on the planet. And I gave up the NRC postdoc, and my thesis advisor said, nobody gives up an NRC postdoc. What are you doing? But to be able to do research at the Smithsonian and also be able to tell kids about it and teachers about it and families about what it's like to be a researcher was really, really important to me, because research and education went hand in hand. And so maybe what I should really start off by telling you a little bit about the emotional experience behind what I did as a researcher. And I could tell you that my friends and I at Goddard Space Flight Center had to build a very special machine called an infrared heterodyne spectrometer. This was my graduate work at Goddard Space Flight Center. And we would take this machine, which would fill a nice-sized classroom. It was a big machine. Out into the middle of the Pacific Basin, and we would take it to the top of Mauna Kea, which is on the big island of Hawaii. We'd take it up 14,000 feet, almost 3 miles into the sky, hook it to some of the most powerful telescopes on planet Earth, point it to planets tens of millions of miles away, and we would measure temperature and composition of the atmosphere. And the very special laser system that I built, which was my baby, allowed us to measure gentle breezes on these planets. So we were able to build a model of the global circulation, the global winds of these planets. And so I was sort of like an interplanetary weather guy. And I could talk hours about why you would want to do that, why you would want to look at weather across the family of worlds as a means of getting a better understanding of what drives weather here on Earth. But I really wanted to talk about the emotional context of what it was like on Mauna Kea. And in fact, I have a slide of this. This is the Summit of Mauna Kea, and you see some of the most powerful telescopes on Earth. This is the Keck 1 and 2 telescopes. This is the telescope that we used back in the mid-1980s through the early 1990s. It's the NASA Infrared Telescope Facility. And the Summit of Mauna Kea is really interesting because, let's see, this is Subaru. This is the Japanese National Telescope. Does anybody know why it's called Subaru? What do you see on the back of a Subaru? It wasn't named after the car. What do you see on the back of a Subaru? What's the symbol? Stars. In Japanese, Subaru means the Pleiades. And so this is the Japanese National Telescope. And you go up to the Summit of Mauna Kea, and you go up towards the afternoon, right after dinner, which is your first meal of the day. And you work all night, and you come back down, and you go and have breakfast just before you go to sleep. And you have breakfast with people working from all over planet Earth. I mean, scientists from every corner of this planet. And you sit down over breakfast and you talk about what you're researching. And somebody might be looking at planetary atmospheres, or somebody might be looking for planets around other stars and how the universe was born or how stars form. And it's just a remarkable experience because this place knows no national boundaries. It's about humanity pushing the envelope. And so a few years back, a teacher came to me at a professional development. She said, what does it feel like to work on the Summit of Mauna Kea? What does it feel like to do research up there? And so I thought about that, and I came up with really 3 levels of emotion that you feel on the summit. The first thing that's really remarkable is that when you go to the summit of Mauna Kea and the puffy white cumulus clouds roll in, they roll in a mile below your feet. So you're like on a rock floating in the middle of the sky. And when the sun sets, and the sunsets are absolutely spectacular, countless stars, 10,000 stars fill the heavens. And if you've been to a dark site here on the surface of the earth and went, oh wow, looking up at the heavens, that's nothing compared to what you see at 14,000 feet, almost 3 miles into the sky. And so here you are on the highest point on Earth, looking out into the universe. The Milky Way galaxy is this double band of white that just arches from heaven to heaven. 10,000 stars fill your sky. And the only word that I've ever come up with that has some chance of describing what you feel in that moment is majesty. You are standing here looking out at majesty. And what's really remarkable about that story is that you're not looking at it from the outside. You're part of it, and it's part of you, which means that you are the universe contemplating itself. That's a remarkable statement, but it's absolutely true. And the next level of emotion that you feel is when you shift your gaze down to the horizon, you see all of these instruments of exploration, this set of powerful telescopes that peer to the edge of the known universe. And you get this overwhelming sense of history, that standing on the shoulders of past generations, this is what we are doing. That you are part of a legacy of human exploration. And the way that it works is quite remarkable, because every generation adds to the body of knowledge, every generation grows frail, and every generation in that moment reaches down to the children and says, it's your turn to take us where we've never been. It's your turn. And be content in knowing that all of the knowledge that was passed to me by prior generations I give to you. And all of the knowledge that I've acquired in my generation, in my time, I give to you. Take us where we've never been before. And after all of that sweat and toil, this is the state of human exploration, pushing back the envelope of human understanding in terms of Earth's place in a greater space. The third level emotion is really personal, and I guess it happened when the laser system that I built is really persnickety. It's got a detector that has to be kept cold at liquid nitrogen temperatures. The laser itself has mirrors on actuators where the actuators have to have a certain high voltage feedback on them. And so you're constantly babying this thing. And so in the middle of the night, something like 3 or 4 in the morning, while my friend is controlling this massive telescope with a joystick, we were looking at Venus at the time, and there's this big image of Venus on the TV monitor with a crosshair as to where we're taking the data. I'm sitting there playing on my laser, getting it all back to normal, and I realized, hey, this is really cool. Look what you're doing. You're seeing, for the first time, the winds of Mars, the winds of Venus, and you started out in Little Red Train Nursery School. I remember that moment. I started out, and if I go to a classroom and they say, where do you go to school? I say, well, I started in Little Red Train Nursery School, and they kind of grimace because they're trying to figure out what university you went to. But the point is, I started out in Little Red Train Nursery School, and I figured out those gifts that I had and those things that I love, and I worked at them. And I got to a point where I made decisions along the way. I got to the point where I was on the frontier of human exploration. And every time I took a personal step to places I've never been, I took the entire human race with me. That's what exploration is all about. And it doesn't matter if it's science or art or poetry. If you put brush to canvas in a way nobody's ever done before, or prose to paper in a way that nobody's ever done before, or in athletics you do something that's quite remarkable, you're pushing the envelope for the human race. You're taking us all where we've never been before. And what I realized was the power of one. That one person has the ability to set their sights in a certain direction and take the race where we've never been. The power of one. And so those 3 levels of emotion, again, are the sense that you're part of this universe, this majesty, And you have the ability to reveal how she operates. You've got this sense that you're part of a lineage of human explorers, that we've been doing this for countless generations, and working together we're doing remarkable things. And you get a sense that just one person has the ability to do something quite powerful and extraordinary. I'm describing science. And I think that you hear in my voice a level of emotion which, goes contrary to the way you normally picture scientists, right? Look, I don't wear a pocket protector. I don't have a white lab coat. I know a lot of my friends do have white lab coats, but I don't associate with pocket protectors. I don't know. That's not true. I just don't have one. But the point, though, is that science is a very emotional experience. And in fact, let me broaden that to human exploration in general, because in a little while I'll talk about science, and I think the point that I really need to make is that science, the scientific method, which by the way is taught badly often as a rigid recipe for success as opposed to an art form, the scientific method is a misnomer because science doesn't own it. It's the way we learn. It's the way we explore, and that's discipline independent. So let me just say, and let me ask you if you all have the definitions down, because I want to tell you a little story very fast. Is the sun a star? How many folks are science majors? I was going to say education, education undergrads? Maybe, sort of? You're on the fence? Okay. Who else is here? This is an audience participation situation. Education grad students. Anybody else? Science grad students. Okay, so good mix. So I have to ask these questions because it's a good mix. Is the sun a star? Like the stars in the sky? You sure? Okay, why does the sun look so different? Why does it look so big and bright? Because it's really, 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 really close, right? What's a galaxy? If you're all stars, what do you call it when stars like to hold together? Galaxy, and our galaxy is the Milky Way. Okay, good. So here's the story. You all live in Ithaca, New York, in an apartment or a dorm or a house in the state of New York, in the United States of America, on a continent called North America, on a planet called Earth, in a planetary system called the solar system, which is the family of a tiny little dwarf star we call the sun in the local solar neighborhood in the Orion spur of the Milky Way galaxy. A galaxy, by the way, which has enough stars to give 50 stars to every human being on Earth. And the Milky Way galaxy is in the local group of galaxies next to the Virgo cluster of 1,500 galaxies, part of the Virgo supercluster of 50,000 galaxies, which makes up the tiny little sliver of the universe that nature allows us to see, called the observable universe. And that is your address. That's your address. And I, by the way, think it's high time that every child on this planet is given the opportunity to learn that address, because the human race needs quite a bit of humility. A good way to say it is we all walk around like ships on the ocean at the center of a horizon, a personal horizon, and we have the hubris to say that that's the center of the universe. Let me say that again. We all walk around day to day just like ships on the ocean, at the center of a personal horizon. We could see out in all directions uniformly, and we have the hubris to think that that's the center of the universe. It's the center of your universe. And I think it's important for us to have a better understanding of Earth in a greater space. So let me now just quickly, did you like that story so far? Okay. Let me just quickly show that to you in photographs. This is the nature of our existence, and if you go above Earth's atmosphere, you get to see the starry sky. And one star looks big and bright. That's the sun in a natural context. The sun is just another star. It only looks so big and bright because it's really close. And it's a small star. 1 million Earths can fit inside the sun. 1 million Earths can fit inside the sun. Does anybody know the name of that star in the shoulder of Orion? Betelgeuse. 800 million suns fit in the star Betelgeuse. 800 million. If you put Betelgeuse where the sun is now, we'd be inside it. It would swallow the orbits of Mercury, Venus, Earth, Mars, and Jupiter. Pretty cool. Okay, here is a picture of the Earth from space. This spaceship with all known life aboard, where water, air, and land conspire to give rise to life. Whether it's a bacterium that calls a drop of water home, or a blue whale that calls an ocean a home, this spaceship is teeming with life. And here is a photograph of the continental United States. And what you see is California is in daylight, and there's the Pacific. Nightfall sweeps westward at about 700 miles an hour at this latitude. And in its wake, we can see ourselves, the entire eastern seaboard lit up with humanity. That's us at night. And here is a photograph taken not too long ago, a few months ago, by the Solar Dynamics Observatory of the sun burping. And that's the actual size of us. And here's a photograph taken by the Messenger spacecraft in January of 2008 as it rounded the side of Mercury the human race had never seen. And this craft came from the Earth. It came from a tiny little blue world, which is right there. That's you from Mercury. And here is a photo. This is a digital image of what the Voyager. Well, let me say it differently. In February of 1990, the Voyager spacecraft was just beyond the orbit of Pluto, and a gentleman who you may recognize, Carl Sagan, suggested that the Voyager spacecraft turn its camera platform back and image the solar system from the outside, or at least outside of the planetary domain for the first time in history. He actually got pushback for that, but he was successful. And so these are the photos that these are the orbits of the planets from Voyager's vantage point in February of 1990. Here are the photos it was going to take to look at Neptune and Uranus and Saturn and Mars, and Earth is in here. And here are the actual photographs. And there's Neptune and Uranus and Saturn and Venus. Mars was actually not in the photo. Jupiter. And ladies and gentlemen, that's you. Voyager is traveling at 40,000 miles an hour. That's twice as fast as the International Space Station or the Space Shuttle. It could orbit the Earth. It could go around the Earth at that speed in 45 minutes. And at this incredible speed, to get to a nearby star will take 80,000 years. 80,000 years. And that's just two stars. Us and a nearby star. There are enough stars in the Milky Way galaxy to give 50 to every human being on planet Earth. And we now know that the vast majority of those stars have planets of their own. And so this is you. From near Earth, from near space. And if you go out into the Milky Way galaxy, you see these clouds of gas and dust from which stars are born, called nebulae. And here are a few Milky Way stars that get in the photograph. And this is known as the Eagle Nebula. And here's a picture up close by the Hubble Space Telescope of this region here. And these little pink things are solar systems that have just been born. We're seeing where we came from. This is an entire solar system, planets and star, being born. And what I'm about to show you is a photograph in the direction of Sagittarius of the closest star to us, Proxima Centauri. It's in the very center of the photo. And if you take a picture of Proxima Centauri, a few Milky Way stars get in the way. And, you know, this is like 50 stars, and this is like 50 stars, and 50 stars, and 50 stars. So how many blocks of 50? Maybe 15 and 15 across. 225 blocks of 50 stars. This is enough stars to give 225 people 50 of their very own. That's all. This is nothing. This is less than nothing. And you see that star right there? I think somebody's looking back. Next time you look up at the night sky, think about this. I firmly believe somebody's looking back. And this is what we think we would see if we left our home galaxy looking in from the outside. This is what 300 billion suns looks like from the edge. And if you looked from above, we'd see something like this. It's a spiral galaxy where the spiral arms are the sites of star formation. And this is a really cool photograph because there's a star because I can see the spikes over here, the crossed spikes. And here's a star. And I'm losing sight of any others. Maybe this one looks like a star over here. What are these? These are galaxies. These are all galaxies. Every one of these galaxies on average has enough stars to give 50 to every person on Earth. And you know how many galaxies we think are in the observable universe? Enough galaxies to give 50 galaxies to every person on. Are you feeling small yet? And here is another photograph of galaxies. And so, has anybody ever read Horton Hears a Who by Dr. Seuss? My favorite book by far. I say, murmured Horton, I've never heard tell of a small speck of dust that is able to yell. So you know what I think? Why I think that there must be someone on top of that small speck of dust, some sort of a creature of very small size, too small to be seen by an elephant's eyes. We are the Who's in Whoville. And if you read that book, you know that the Who's were calling out from a speck of dust, and Horton was listening with his incredible hearing, and he was having this conversation with the Who's in Whoville, the mayor of Whoville, and he spent the rest of the book trying to convince the jungle creatures he wasn't a crazy elephant. We're the Who's in Whoville, and we're calling out to the rest of the universe. Not only with spacecraft, but ever since Marconi turned on the radio in 1896, radio and then television have been moving out at the speed of light, and thousands of stars are now bathed in human signal. We're calling out just like the Who's in Whoville. And I think that the real question that you have to ask in all of this, how did we reveal all this from this tiny little world? The story that I told you, that I started off by saying, hey, I'm on the summit of Mauna Kea, I'm looking out into majesty, and then I tried to convince you by telling you your address and walking through those images. Yes, it is a majestic universe. How did we reveal all that? Let me say it a little differently. How did we reveal all that with something the size of this? Something the size of this gave rise to that story. Where did it come from? What process did we use? What is exploration? What is human exploration? What are the fundamentals of how we approach pulling back the veil of nature on any facet of the universe and seeing how she operates? Sort of a rhetorical question, not completely. Yes? Asking questions. Observation. Anything else? Discovery. Curiosity. Inquiry. I'm just fielding words here, okay? Listen to all these words. They're all very powerful. Anything else? All right, let me go on to the next chapter. Why do we go to school? I'm now going to walk you through my view of how we revealed the majesty of the universe, that story. Why do we go to school? Why do you go to school? Think about kindergarten, elementary school. Think about college, your college career here at Cornell. Why do you go to school? I'm not going to bite, I swear. I'm not going to bite. There's no wrong answer. What? To learn how to learn? I would argue you already know how to learn. It just takes a little bit of coaxing. Anybody else? Why do you go to school? Okay, here, let me switch roles. Poof. I know you're not going to want to do this, but you're all parents.
What are we going to do with the kids during the day?
What do you expect your kids to say in answer to a question, why do you go to school? Parents? I'm sorry? To make the world a better place. That's a great answer. I suspect there are a lot of parents that will not say that.
Yeah, I think parents are going to think about it from the perspective of what they consider to be success for their kids.
Okay, what is that? What is that?
So they can essentially make a living, get a job to support themselves and their family, to, in a sense, reproduce the family and keep it
Okay.
sustainable.
So when I go to, yes?
You want your kids to do better than you did.
Okay, that's a profound statement because it's so far-reaching. But let me tell you what I hear when I ask elementary and middle school kids that question. Okay, and try to see whether or not that extrapolates to your reason for being here at Cornell. Kids will say, I want to go to school, I need to go to school because mommy and daddy say so. That's the first thing you hear. I need to go to school because I have to get good grades and get a good job because I have to make money, right? And if you get the higher grades, well, I need money because I want a car, and then you say, well, you're going to eventually want a family, and you're going to want to have a mortgage, you're going to or rent, and you're going to have to put food on the table, and that's the reason we go to school. Do you buy that?
Sure.
That has absolutely nothing to do, in my mind, with why we go to school. It's all wrong. And let me start off by saying something maybe profound. When we explore, we fulfill a commitment to our own humanity. I don't know, you should ask your parents this. I don't know if you've ever had this conversation with them, but if I were to ask parents, do you remember that magical time when your children were first starting to express themselves with sentences? And as a parent, I know what that magical time was like. I lived through it with my son. You've lived through it with your daughter. I lived through it with my daughter. That magical time when they're first able to communicate with you and express themselves. And all parents will remember that time. And then you ask, what did your kids do when they first were able to express themselves? Somebody said it in one of the words before. What? Why? Which is a question. Kids will start asking this unending stream of questions. So many questions, so overwhelming are the questions that adults tend to try to squash it because they can't handle all the questions. So as soon as we're capable of expressing ourselves, we ask lots and lots of questions. And I had to change the way I said this when my son was born, because I remember I was in a family room with my son who, and this was before he was able to speak. He just knew a couple of words, that's it. But he was an avid reader. And the reason I say that is we had this incredible library of picture books. Do you remember those big format picture books where like every tree imaginable was on these pages in the tree book? And then there was the car book and the truck book. And I remember this moment in time when we were sitting on the family room couch, and I think it was the fish book. And I turned the page, and he pulled the page back, and he looked at me and went, "Da." And I didn't know what he was saying, so I turned the page again, and he pulled the page back hard, and he went, "Da, da." And then I didn't know what he was saying, so I turned the page, and he pulled the page back really hard, and he pointed to a particular picture. I can't remember what the fish was. Let's say it was a tuna. I don't know. And he said, "Da, da." And I looked down and I said, "A tuna." And he turned the page. And so what he was saying is, "Daddy, what is this?" Before he even had the ability to express that, to say, "What is this?" he was asking questions. We're born to explore. We're born curious. We've got to do it because it's what it means to be human. And we're also born with something else. So we're born curious. We're born to ask those questions. We're born evidence-based learners. What does that mean? Well, we are born to poke the universe and see what happens. We love to poke the universe and see what happens. And a great example of a class of humans that poke the universe really, really well are babies. A baby will poke the universe in every way it can. It will explore near versus far and up versus down, texture and color and sound. A baby will try to figure out how to bring that glass of juice in a way so that the surface remains horizontal until the child can get the glass to their mouth and then drink it. Think about the articulation in the fingers and the wrist and the elbow and the shoulder to make all that happen. And the act of poking the universe and seeing what happens gives rise to two things. First of all, it tells us how the universe works. And the second thing it does is it tells us how to interact with the universe. We learn how to interact with it because of the evidence it presents to us. So that's really, really important. We are born curious and we are born evidence-based learners. So let me start back with that first part. Let me not say that, give the answer away. Not knowing something is a gift. Why?
Explore it for ourselves and have fun doing it.
And how do you start that exploration?
By asking what it is we don't know.
Asking a question, right? Not knowing something is really a remarkable gift, because if you don't know something, you can ask a question and have a journey. That's what it's all about. And I guess the only caveat is that you want to know it by the time the exam rolls around. So the act of journey, the start of journey, is brought about by asking a question. And so let me give you some examples of the majesty in a question. There are common themes here. I use the word majesty a few times sparingly. There is majesty in a question. And I was doing a professional development with zoo staff at the National Zoo in Washington, D.C. And we were talking about this. And Roger Roscoe, who is a curator in the Reptile House, said, "Jeff, I know what you're talking about, because there was one question that drove everything I did as a kid when I wanted to go out and explore." And I said, "Well, Roger, what was that question?" He said, "I wonder what's under that rock." And so this was the question that drove him. I wonder what's under that rock. And he would go and he would empower himself as a learner to lift up a rock and see creatures that he never would have seen if he didn't ask the question. This brave new world of creatures that live under the rock and don't want to come out in daylight. And so with a smile breaking across his face, you know what he did? He said, "I wonder what's under that rock, and this rock, and that rock." And after he had done that with all of the rocks in his backyard, he moved over to the park. I mean, this is what he told me. And that love of exploring the world translated professionally into he became a curator at the Reptile House at the National Zoological Park. And I said to Roger at the time, "Well, that's really cool, because when I was in elementary school, there was a question like that I used to ask. I wonder what's in that rock." And I took my dad's hammer and I would whack away at rocks. And it was like on the outside they would be brown or gray, and inside, hey, this is really cool. There's quartz in here. And I'd go to the museum and I would see geodes. Have you ever seen geodes? And it's like I would just whack rocks all over the place. And I had this rock collection, which I probably still have. It's somewhere in a box somewhere. And I know I've told that story to a number of geologists who said that's how I got involved in geology, whacking rocks open. Think about another question, and some of the most powerful questions are the most elegant. How far can I see? So on a clear day, if you're out in an open field, how far can you see? What do you think?
A few miles.
A few miles? Yes? You agree with that? Well, wait, can you see the moon? That's 240,000 miles away. Can you see the sun? That's 93 million miles away. That star Betelgeuse in the constellation of Orion, which you can see from any urban area because it's so bright, that's 500 light years away. 1 light year is 6 trillion miles. That's 500 times 6 trillion is 3,000 trillion miles, and that's a nearby star. If you're in the southern hemisphere, you can see the large and small Magellanic Clouds, 2 neighboring galaxies. And if you know where to look, you can see the center of the Andromeda galaxy, the nearest large galaxy to the Milky Way, and you're looking 2 million light years away. That light started traveling to us 2 million years ago and is only getting to us now. You can see really far. And so that one question, how far can I see, provides this pathway for a journey of discovery that's stunning. It's absolutely stunning. So a question is really, really powerful. And here's something that I think ought to be an appropriate reminder to any adult, okay? Next time a child comes at you with question after question, consider it a gift because they chose you. You're helping the next generation of explorer fulfill their commitment to their own humanity. People are taking notes. Follow me on Twitter. You can see many of these are short enough for 140 characters. There's a reason for that. How do you answer a question? Well, will that give you an answer if you answer a question with a question? Well, okay, how would you answer, sophisticated audience, a question? You'd go to Google or Bing, right? But wait a second. Is that how you answer the question, or is that eavesdropping in on somebody else's answer to that question? How do you answer the question? You poke the universe. You've got to find a creative way to interact with the universe. And in the case of my field, astronomy, it's really cool because light from all of those things that we were talking about before is streaming to the Earth, and the Earth gets in the way. And that light falls without any importance on the surface of the Earth, and it's gone. But if you poke the universe, if you interact with the universe by putting large light buckets in front of the light streaming in, we call them telescopes, and you collect the light and you're smart enough to understand the information contained in the light, you can find out how far and how bright and how big and whether the winds are circulating on the atmosphere of a planet far, far away. So how do you answer a question? You've got to interact with the universe. Now, I think what I'm trying to say here is that what we know, standing on the shoulders of past generations, has come to us because we have found creative ways to explore. And what we're doing when we're just children is naturally exploring. We're not learning how to learn. We already know how to learn. Babies know how to learn. What we really need is a little guidance. It's sort of like it's the student's classroom and the teacher lights the way. Okay, it's not the teacher's classroom. It never was. It was never meant to be the teacher's classroom. It's the student's classroom and the teacher lights the way. The idea is that we know how to learn. We know how to poke the universe. We know how to ask questions. We know how to frame a pathway to an answer. But sometimes you need to herd the cats a little bit to provide the tools that will allow it to be a very efficient exploration. So, what is science? Because I've talked about what it means to be human in terms of exploration. What is science? Because formally, science is what revealed the majesty of the universe. What is science? If you ask scientists and engineers, what do? What would they say?
The art of generating new questions from old questions or something like that.
It's a way of knowing.
Way of knowing. How is that different than what we've just been talking about in terms of human nature, in terms of exploration? It's not?
It's more. You write it down.
I like that. Can we use that on Twitter? You know what science is? It's organized curiosity. It's organized curiosity. And you know what science is? It's evidence-based learning for the entire human race. It's evidence-based learning for the entire human race. Science grows organically from what it means to be human. We're born curious, organize it, you get science. We're evidence-based learners. Organize that into a process by which you can really put evidence to the test, you get science. Think about it. I'm a scientist. I go and I find out something new. I'm really excited about this new thing I found. I tell all of my colleagues through scholarly publications and at conferences. I tell all my colleagues about what I found. They say, I don't believe you, Jeff. You know what I say? Well, you poke the universe the same way and see what you find. That's what science is. It's a torture test. You make your evidence, you're an evidence-based learner. You've figured out what the evidence is. You've presented it in scholarly publications. And now you invite the entire scientific community to throw darts at it. And you know what happens sometimes? You find out you were wrong. And you know what happens sometimes? Everybody finds out the same thing, and it's like the whole world goes to a whole new place. So science, as I said, is a natural outgrowth of what it means to be human. So the next logical question in this story is, what should science education be? There's a pathway. I'm getting to a point here. And let me go back to something I said earlier, which is that the process by which we ask a question and the art by which we frame a pathway through the noise of the universe around us in quest of an answer, and the act of pulling back the veil of nature and seeing something wholly new, and the joy that breaks over breaks across your face when you see something wholly new is science. Where was I going with this? Science education. Well, that process, in an organized way, is the scientific, well, let me say it a little differently. That process is the scientific method, and it's an art form. It is not a rigid recipe for do this, do this, do this, do this. I could tell you that two scientists approaching the same problem, may go at it completely different ways. And one scientist approaching two different problems, well, they may go at it two different ways because the problem demands it. And I can tell you there are scientists that will not hypothesize to begin with because they don't want to bias the results. Lots of science is done by poking it and just seeing what happens. So the scientific method, I think we do a very bad job in teaching in classrooms. But the more important thing is that process of exploration and learning that I described, is that science specific? What about history if you want to learn about the Civil War? Instead of parroting facts and information and here memorize all of this stuff, or let's say Truman, the decision to drop the bomb, instead of a bunch of facts and figures to memorize for the exam, you're Truman and his Joint Chiefs of Staff and his cabinet. That's who you are. You're making the decision to drop the bomb. What is it that you would need to consider? In other words, you can put students in the moment, provide them a problem in history, and history becomes alive. It becomes something that is more organic. And so I think what I'm saying is that process that I'm describing here is the way humans like to learn. It's the way we're born to learn, and it's discipline independent. And so therefore, my question becomes, how then should education be conducted so that it's effective education? What should, and I'll give the example of science education, what should science education be? What is the nature of science education if it's going to be effective? And so let me take you through a couple of other things. My thoughts on education. Some of my thoughts on education. A question we should be asking but don't. What is the role of education? You tell me, what's education all about? What's the point of education? What's the point of going to Cornell? What is the set of objectives that you're trying to meet? And I'm not talking about, downstream, the job, the diploma, the education. What's the point? I'll give you a hint. Here's a tweet I put out that went viral. Student, why do I have to learn all this stuff? System, because we want you to get a good job as a search engine. What do I mean by that? I'm sorry?
You can find all that stuff online.
You find that also, so it's important for you to know all of the state capitals by the time, say, you're 10 because that information's hard to come by. How many of you in your, you've gone through a K through 12 education system, how many of you remember subjects where the educational experience was memorizing information? How do you feel in the age of Google? It's like 10 minutes, okay. I actually saw that. That's good. That's good. You didn't have to throw anything. Okay. What's interesting is I used to tell students years ago, I'd go into a classroom and they wanted me to talk about careers and, how I made my decisions and what I did. And I used to say something that I now kind of sort of regret. I used to say to students, knowledge is power. The more you know, the more capable you are to decide what you want to do with your life. So school is really, really important. You got to know, as much as you can. That's really not right. That's not correct. What happens if all of a sudden somebody finds this humongous deposit of gold? What will happen to the value of gold?
Go down.
It'll plummet because there's a lot of it. Well, look at Google. Look at the information age. Look at the knowledge base of the human race online. And in the not too distant future, I'm sure a couple of generations from now, you're going to be able to plug your brain into the human knowledge base. And what then of education? Knowledge, and let me say this for effect. I don't believe it to the depth of what I'm about to say, but I'll say it for effect just to make the point. Knowledge is virtually useless. It's everywhere. We were driving in the car and we were talking about William Penn in Philadelphia, and we were having this debate. Well, William Penn must be like 5-10 stories high, and I pulled out my iPhone 5 and it's like 547 feet high. William Penn is 54 stories up in Philadelphia. That's like incredible. It's like I have the power at my fingertips to probe the knowledge base of the human race. And so the power doesn't lie in how much you know. The power lies in your ability to do something with the knowledge. What's power is your ability to use the knowledge, to do something with the knowledge. And actually that's true in virtually every field. A bold statement. When it comes to education, we must stop telling our children that knowledge is power, and we just talked about that. And so it's not about the information. Education should not be about the information. And over here, education must not be about dictating to our children what they should be curious about. Do you know what's really reprehensible? Forcing a child to sit in a classroom for 6 hours and telling them what they should be curious about. That denies them, I think I said it on the next slide. Here it is, okay? Education that denies our children their curiosity and their need to poke the universe is not education worthy of our children. It's the student's classroom, not the teacher's. The teacher lights the way. And if we take away ownership and learning from the child, what we are doing is denying them their need to be explorers. And there are the ways to do this. What I'm suggesting here is not difficult to do. So going back to what is innately human, the journey is written in our genes, the book of knowledge is not. What should that tell us about the role of education? Okay, let's go back to biology. The journey is written in our genes. Do we have to teach our children, those babies, for instance, how to explore their universe? The journey, the process of inquiry and exploration is written into our genes. The book of knowledge is not. So what should that tell you about education? How education should proceed? Shouldn't it be nurturing what is already in us? Shouldn't it be about nurturing the gift of a question and inquiry-based exploration? Shouldn't it be about recognizing that there is core knowledge? Let me say it this way. When you ask a question, if you understand how to play the game, the art of learning, you recognize that there is core knowledge that you need to bring to the problem at hand. And there is core knowledge that we ought to be teaching our children, basic conceptual underpinnings across the board. And then you find a pathway to address that question, and the answer is the creation of new knowledge. The objective ought to be a student's ability to go through that process and create new knowledge, at least new knowledge to them. So education, and the title of the talk was A Teacher's Gift, Nurturing Education in Our Children. What education ought to be about is that nurturing of exploration in our children, nurturing exploration in our children. Now, let me give you some examples, okay? And maybe this is on the next slide. What do I want to say? Let's go to the next slide. It's been a long day already, okay? Okay, well, I didn't get to the other slide, but yeah, education needs to be about journey. It needs to be about process. And what are the skills required? Ownership and learning, critical thinking, problem solving, navigation of an interdisciplinary landscape, teamwork. Ownership and learning is so important. It's like, here's an example for, elementary school generalists. It's like, are you telling me that you want me to allow unfettered exploration of my science class, letting all of the students go and do whatever they want? And I understand that problem. And I can tell you, when I was building the carbon dioxide laser system for the heterodyne spectrometer, no divine hand gave me the procedures on how to build it, nor would I have taken it. As soon as a science teacher, say, gives procedures for an experiment to their class, they're ensuring that no science is going to be done that day. Why? Because who owns the procedures? The teacher. You've taken all of the ownership away from the students. You're asking them to be technicians. Follow these procedures. But a creative compromise is for you to, with the class, explore the problem at hand so your class comes up with the experiment you happen to have written up. Do you hear what I just said? Okay. A good teacher, an artful teacher, will be able to facilitate conversation in the class so that the class moves in some direction. And if you can get your students to come up with the experiment you happen to have written up, why is that a difference between night and day? Who owns it then? They do. And that's really, really important. So ownership and learning is important. Critical thinking, understanding, logic. I think that there should be a bar that has to be passed for people who want to go into public office. They have to pass a critical thinking test. I don't understand. I was saying this to a couple of people. Aiken, the famous congressman who said that in case of legitimate rape, a woman has the ability to shut down a pregnancy. And Braun from Georgia, who said that evolution and the Big Bang are the biggest lies of the devil. And here's the insanity. Both of these gentlemen sit on the U.S. House Science, Space, and Technology Committee. Okay? So, we have a problem, ladies and gentlemen. Okay, problem solving. That art form by which you take a question and find a pathway to an answer. Navigation of an interdisciplinary landscape. How many of you took, trigonometry and calculus? Remember that? Okay. Do you know how many students that take trigonometry and calculus ask this question, why do I need to know this stuff? Because the math is taught in full isolation from actual use. Math is the language of nature. If you want to understand her and understand how she operates, you have to speak her language. It's a language. And if I were to teach French, and you were never going to use that French to talk to other people who speak French, or go and read the literature and newspapers in French and understand the French culture. If you were never to do that, why would you want to take French just to memorize vocabulary? Why would we subject our students to these stovepipe math courses with no connection to why math provides the ability for the human race to see. So interdisciplinary landscapes, you got to navigate. It's not like opening a physics book and closing it, and opening a chemistry book and closing it, and opening an art book. Life is an interdisciplinary tapestry, and education ought to mirror that. Maybe I'm asking too much for the education system, but what I'm simply saying is that education ought to be nurturing what is natural to human learning. So, and as an example, as a working example that I'm familiar with in terms of science education, which is now called STEM, okay, if you've been doing good science education, it had to be STEM because science, technology, engineering, and math cannot be done in isolation from each other. But my view is if exploration is something that our children are born to be able to do, and science is nothing but organized curiosity and evidence-based learning for the human race, our children are capable right now of being immersed in real science and doing science, which means that science education could be about modeling real science, immersing kids in science, letting them be scientists and engineers right now. Not talking about the science knowledge base. The book of knowledge is not science. That's what you get from science. Or talking at science. Let them do science. And the program that we did to really put that to the test, which has been very successful, is the Student Spaceflight Experiments program, where we can say to a school district, we're going to give you your own space program. We're going to give you a real microgravity mini laboratory and all launch services to get it to the International Space Station, have an astronaut assigned as a technician to operate the single experiment it contains, return it safely to Earth. And just like NASA, that school district at the local level says to at least 300 students, you're all scientists. And break into research teams, and each team design your own microgravity research program. And each team write your own research proposal, which will go through a formal two-step proposal review process, just like professional researchers. And one of those teams will have their experiments selected for flight. And we're doing this with fifth graders, grades 5 through 12. And it is stunning what we're seeing. We've had 21,700 students fully immersed in experiment design and proposal writing, over 4,000 proposals, all this since 2010. Students are saying, I never knew this was science. Teachers are saying, wow, this is a completely different way to teach science. A project-based approach, immersing students in every facet of real research. And they even get their own research conference at the Smithsonian's National Air and Space Museum. So I have obviously, oh, we're out of time, I gotta stop. I obviously have some very strong opinions about human exploration, science and science education, and more generally, human exploration and professional exploration and how we teach in an interdisciplinary way subjects in the classroom. But I also have a track record for putting that into practice. And I think that what we are in right now as a test-based educational system that stifles creativity, that denies many learners the ability to be curious, that forces testing, education to serve testing and not testing serve education, is a recipe for success. It's a recipe for success for China. Oh, I pulled that out at the last minute. Okay, so I think I'll stop here. I'm certainly able to answer any questions if people want to mill around or.
This has been a production of Cornell University, on the web at cornell.edu.